Hello, still February 18th. Thought I'd just have a go at problem 7. You see, I was studying chapter 3 in the spring of 2021, and I encountered this function which was defined somehow, I don't recall how, by this character. And then I would try to do all the work with another character of modulo 12. And the formulas I derived were wrong. That kind of shook me. I realized then that there must be some things about the characters I didn't know, particularly the word primitive. So you see, this is the primitive character of a modulo 12. So one can make an extension of the character modulo 3 or modulo 4 and get other characters modulo 12. And I was using one of those. And then you don't get a function you can work with. They define eta by using the theta function, and it doesn't say the theta function from which problem. So I believe it's the most simple one from problem 4. So let's see what we get using that. Sorry, the telephone rang, planning going to the cinema this Monday. Well, let's get into it. And I believe we must use this guy. Oh, actually we only worked with this guy for t being real, and now we introduce an imaginary variable . That doesn't bother me. But then which square root must we take here? So the square root of a real guy maps to the positive square root. And that's exactly what it says here. The square root of z divided by I agrees with that. All right. So let's substitute into this equation t equals minus iz divided by 12. Divided by 12 square root minus iz divided by 12 times theta, and chi is real, so it's the same, and then 12 divided by I z 144. Let's just check that. N squared, that's 144, and 1 divided by t, that's 12 divided by oh yeah, minus I z. I already put it on top, but I write it at the bottom. To reduce this, we need to compute g of chi. And our psi, this is 30 degrees, so it's cosine, that's square root 3 halves, point sine, plus, yeah, I halves. And the only guys that matter is 1/12, 1 minus 1, and 5 and 7. I'm going around with the angle of psi. So these are plus 1, and these are minus 1. Four times square root 3 halves. It's plus square root 12. That means we get square root 12 here, which cancels, which together with this square root 12 up there gives 12, cancels that. So it's 1 divided by the square root of minus I z, theta of chi, and we put I up here. I divided by 12 z and this is just equal to n of 1 divided, minus 1 divided by z. So what should we prove? It's square root of z divided by I. Yeah, it's just putting this over on the other side. And then it's the same as square root of z divided by I, eta of z. It's really the same branch, so no problem. That finishes that.